All right, guys, here we go. Notes 11, Pythagorean Reciprocal and Quotient Properties. So I think some of you might have heard that this was tough. It's not. Let you be the judge of that. You'll see it's not that bad. So what do we already know? We know that secant x is 1 over cosine, because secant and cosine are reciprocals of each other. Cosecant x is 1 over sine x, and cotangent x is 1 over tan x. So that also implies that cosine x is 1 over secant x, because secant is reciprocal of cosine. Sine x is the same thing as 1 over cosecant x, and tan x is 1 over cotangent x. So that implies that as well. Have we done anything that you do not know? No, not yet. No. Watch. My bad. No, you pretty much know all of this except for maybe the Pythagorean identities, but you're gonna know it really quick. Remember that tan is also the same thing as sine over cosine, and that cotangent is the same thing as cosine over sine. Do we have any issues with that? With this, what the tan is sine over cosine and cotangent is? Okay, so we're good at that, right? Okay. All right, so yeah, because remember we said sine is like y and cosine is like x, so tan is y over x. So okay, so all we're doing is transforming trig expressions, guys. That's all we're doing. So look what it says. It says transform sine x cotangent x into cosine x. So I like to write this. I want to say sine x cotangent x, and I want to transform that into just cosine x. Sometimes I put arrows. Sometimes I put equal signs. It just depends. So I take what I have on the left, and here's what I do. I go sine x times, and I'm going to break cotangent down into cosine and sine. Yeah, you can. And then I'm going to put, what did I say I was going to do? I'm going to turn cotangent into cosine and sine. So cotangent is cosine over sine. So I'm going to go times cosine over sine. What's going to cancel? The sine. And OMG, look what you have. You have cosine. So usually you draw 3 little dots in the shape of a triangle. That stands for therefore. Therefore, sine x cotangent x is equal to cosine x. If you don't see me put parentheses in the argument, guys, that's okay. That's fine. Textbooks do that all the time, so that habit. Textbooks should be putting parentheses always, but they don't. Yes. Yes, you're just trying to figure out what are the steps necessary to get to just cosine x by itself. You know what I mean? Yay. Okay. Go to the next page. We're going to go slow. I'm going to exaggerate quadrant 1. Here's quadrant 1. And I'm going to here is from the origin some angle. This is some coordinate x comma y. Here's that triangle. This distance here is x, and this distance here in green is y. Because this is a unit circle, this radius is 1. So katoa, we know that sine of this angle is opposite of our hypotenuse, so y. That's why we said sine is just y. We know that cosine of this angle is adjacent of our hypotenuse, so we say x. And if I do Pythagorean theorem, I'm going to go slow. This is a big point right here. If I do Pythagorean theorem with what I have in that triangle, you would tell me x squared plus y squared equals 1 squared. What do you think, Castro? Not bad, right? Okay. So, what do you think, Kyle? What's the catch? There's no catch. I'm going to do a substitution. Relax, guys. Look, it's not a big deal. Look, what did I tell you that cosine was? And then what did I tell you that sine was? So I'm going to substitute. And I'm going to write it like this. Cosine theta squared plus sine theta squared. And then 1 squared is just 1. See, there's no catch. Side note, I'm going to put it here on the side. Cosine theta with its squared is the same thing as saying cosine and then putting a square after the s with it like that. Do not do this. If you do not put the parentheses and you say squared like that, it's the theta that's being squared and not the cosine. Do we understand? Okay. So this does not equal cosine squared theta. Okay. All right. So here's how I'm going to write it. Here's how most textbooks would probably write it. First bullet, indicating this is my first property. Cosine squared theta plus sine squared theta equals 1. Go ahead.
Can we put the square outside?
Yes, you can, but make sure to put parentheses if you're gonna do that. Like you're trying to say like this one that I'm circling in blue. Yes, that's fine. All right. I know Valentine's is not here yet, but here's how you're gonna memorize this. I call this a Valentine's formula. And before, okay, I'm gonna tell you a little story. It's a true story, but I'll tell you that after I tell you this. You're gonna write a poem to your significant other, to your boy or to your girl. We don't judge here. You're gonna say that you are cosine squared, and your significant other is sine squared, and together you guys are 1. If they don't understand that or they don't get it, break up with them and upgrade. Okay, all jokes aside, teach them that cosine squared plus sine squared is 1. Now, true story. I know of I guess he's a teacher. He's a teacher. He works for College Board, and he has cosine squared tattooed in his wrist, and his wife has sine squared tattooed on her wrist, and they're both teachers. His wife is an elementary teacher, and together they are 1. Cool. I've seen some rings, cosine squared and sine squared. I think that is so cool. You get the cosine squared, you give your significant other the sine squared. Look at all these ideas that we're hitting you up. All right. Here we go. So now you know cosine squared plus sine squared equals what?
1.
Forever and ever and ever and ever. All right. Here's my second property. So I'm going to write it in green. I'm going to start with cosine squared theta plus sine squared theta equals 1. And I'm going to divide every single term by cosine squared. Chav, why are you doing that? Well, I want to get my Pythagorean identities. What am I doing? In case you're wondering, this is called, if you want to Google this, it's called Pythagorean trig identities.
Why do you have to divide them? They're just being added.
Say it again.
Why do you have to divide them? They're just being added.
I'm dividing every single term by cosine squared
Why?
to get my second identity.
Why don't you subtract it?
I don't want to do that yet. You can, but I guess you want to get the derivative of this. So you're trying to say like different ones. You can say cosine squared theta is equal to 1 minus sine squared, I guess. Or sine squared theta is equal to 1 minus cosine squared. I mean, I guess. But we're getting another identity. All right, here's the identity. Here's another one. What's cosine squared divided by cosine squared? 1. What's sine over cosine? Tangent, but I have a square on both of them, so you're going to say tan squared. And what's 1 over cosine? Secant, but because it's squared, I say secant what? Secant squared. So that's my second bullet. I'm going to put a second bullet. Here's my second identity. 1 plus tan squared equals secant squared.
So are we just trying to find all the possible formulas to give us the same answer?
I'm just trying to find my 3 major trig identities all derived from cosine squared plus sine squared equals 1. Trying to make you guys not a robot. You know what I mean? There's three main ones because there's three terms, I guess, technically. You know what I mean? So now I'm going to take the cosine squared plus sine squared equals 1, and guess what I'm going to divide by? Sine squared. When I do that, what's cosine divided by sine? Cotangent, but because I have a square on it, I put a square. Plus, what's sine squared over sine squared? 1 equals, what's 1 over sine squared? Cosecant squared. Good job. There's my third one. I'm going to put my third bullet up here. Cotangent squared theta plus 1 equals cosecant squared theta. You're going to be using these three bullets over and over and over again. It's a property. There. What are they called? Starts with letter P. What did you say? Give me a word in front of the word. Pythagorean trig properties. If you Google Pythagorean trig properties, these three will come out. Pythagorean trig properties. I could have just given them to you, but notice that we derived them all. Do you guys prefer to know where they come from? Yeah. Okay. See, I just didn't say, here you go, just know these. We derived them, guys. We derived them all from the unit circle. They all came from the cosine squared plus sine squared equals 1. Cool? Mm-hmm. All right, here we go. Go to the next page. Look what it says. Yeah, I know, it's getting really warm. Maybe it's all the sun coming in. I don't know. Oh. I'm a polar bear, miss. I need it to be cold. Okay, it's fine. It's fine. Transform cosine squared sine squared into 1 minus 2 sine squared. So what do I want? Cosine squared x minus sine squared x, and I want that to look like 1 minus 2 sine squared x. Haven't done anything crazy yet. I make a side note, and I say the only thing we know right now is our Valentine's formula. I guess we know the other two, right? But I'm going to write the Valentine's formula, and I'm going to write it in terms of x instead of theta. Cosine squared x. As long as the arguments are the same, this will always be 1. Yay or nay? And here's what you say. You look at it. I'm looking at here on the left, and I say, hey, wait a minute. If I want to get to 1 minus 2 sine squared, I notice that 1 minus 2 sine squared does not have any cosines. Do you guys notice that? So I come back to my side note and I say, okay, let me get cosine squared by itself. So I'm going to move the sine squared to the right. Bless you. I don't know if that was a sneeze or not. 1 minus sine squared x. Do you guys see what I did? And I'm going to substitute. Yes, ma'am. Yeah, we did. But I don't need to divide now because, yeah, we're trying to find 1 minus 2 sine squared. And notice these two right here will not help me. So I'm rewriting it. I'm doing that one. So I take my cosine squared. I'm going to drop it. And instead of writing cosine squared, I'm going to write 1 minus sine squared. Minus, that minus is this minus. Sine squared x. Cool or not cool? I'm going to drop the parentheses. Drop it like it's hot. Oh, yeah, whatever. Okay, we're just dropping it. 1 minus sine squared x minus sine squared x. How many sine squares do you see? So 1 minus 2 sine squared x. OMG, look, we got to what we wanted. We put 3 little dots in the shape of a triangle. Therefore, cosine squared x minus sine squared x does in fact equal 1 minus 2 sine squared x. It also equals something else, but we're not there yet.
So we're pretending as if they only give us cosine squared x minus sine squared x, and we're trying to get to that other one.
Yep, we're trying to get to the right-hand side, the 1 minus 2 sine squared x. So here are the intermediate steps required. It really is just one substitution. And then from there you get that answer.
So whenever it's like 7 for example, they just ask all of this true.
You'll probably just have multiple choice. This is equivalent to. That's how it is on the UH. All right, let's go to example 3. They're trying for, they want me to prove that this is an identity, so they're telling me it's true. Child, what am I going to do? Let's go slow. Hopefully you realize that this is a difference of squares, but if not, no big deal. We'll just spoil it out. What's 1 times 1? 1. What's 1 times negative cosine x? Negative cosine x. What's cosine x times 1? Plus cosine x. What's cosine x times a negative cosine x? Perfect. Make sure to put the squared after the f or put parentheses. What happens with my two terms in the middle? They zero itself out. Perfect. 1 minus cosine squared x. And now I'm here and you're like, okay, now what do I do with that? I come up and I take I'm going to write my side note. I'm going to write my Valentine's formula. Don't call it the Valentine's formula to your professor. If you do and the professor asks, where are you coming from? Like say like Jeff or something, Jeff High School. It's not called Valentine's formula. That's what I call it. It's called the Pythagorean trig identity. Cool? All right. I notice this, and then I say, oh, okay, look at this. If I move that cosine squared to the right, I'll have this expression like so. And look at that. Is that 1 minus cosine squared right here? So that is just equivalent to sine squared x. Well, these all need that. Not all of them will. But if you see something with a square on it, more than likely, yes. Put 3 dots in a triangle. 1 plus cosine x times 1 minus cosine x is nothing more than sine squared x. You feeling okay, guys? All right, let's keep going. No, not surprisingly. We're always good. All right, here we go. Prove algebraically that cotan A plus tan A equals cosecant A secant A is an identity. We're going to go slow again, just like we've been doing all the others. All right. I'm going to focus on the left-hand side, and I want to make the left-hand side equal to the right-hand side. So I'm going to write cotangent A plus tan A. Yes, A is just the argument. It can be, you can put a beta in there, an alpha, a theta, an x, whatever. As long as they're both the same. Are we okay so far? All right, let's break down cotangent and tangent into sine and cosine. So cotangent is what over what?
X over 1 over 10.
Yeah, but instead of x over y, we're going to say what again? Remember? Yeah, and then keep the argument, which is the a. So we're going to write cosine A over sine A. That's your cotangent right there. Right? Plus, and then the tangent is what over what? Sine A over cosine A. Good job. Good job.
Why is it equal cos A over sine A plus sine A over...
This here on the left, this is cotangent A. And this is tan A. See? Cotan A plus tan A is still cotan A plus tan A. You know what I mean? All right. I can't add these two unless I have what? What did they tell you in elementary? A common denominator. I heard someone say it. So I need this on the left. I'm going to multiply that dude by cosine A over cosine A. I'm going to multiply this dude on the right by sine A over sine A. Does everyone know why I'm doing that? To make a common denominator of cosine A, sine A. Hey, come on in. Take a seat. Yes.
Okay, so the right one, why are you multiplying the denominator of cosine A by sine A? Is it trying to give it the same denominator?
I'm trying to get the same denominator. Yeah. Take a seat. Don't worry. We're going to catch up. Do you remember all this good stuff? All right, here we go. What is... No, I'm slowing down. I'm going slow. What is cosine A times cosine A? cosine squared A over, and in the bottom, I'm going to write it like sine A cosine A plus, what is sine A times sine A? And on the bottom again, I'm going to write it as sine A cosine A. My denominator is the same. Because they are, I can write cosine squared A plus sine squared A all over sine A cosine A. Are we still okay? I'll wait for you guys to catch up. What do we notice about the numerator? I don't know. It equals something. It's a Valentine's formula, guys. Cosine squared plus sine squared. Yeah, you can't cancel anything out because you can't factor anything out. So if you can't factor anything out, you can't cancel the sine or the cosine. So sine, cosine. Okay, you know what? Let me get back to that. So you guys sometimes like to cancel stuff out. You can't, because it's like you're saying this. If I go A plus B and I divide by AB like that, there's nothing that can cancel out, guys. A lot of you guys like to do this. Oh, those A's cancel out. No, the only time they cancel out is if you can factor out something. So look, there you can factor out an A, and it'll have A plus 1 over AB. There you can cancel out an A, because product and quotient, or multiplying and dividing, are inverse operations. So be careful. You guys like to cancel stuff out like that. What's up, Houston? Tell me. What do you mean? So cosine squared A plus sine squared A is 1. So I have 1 over sine A cosine A. But you wanted me to do what? The exponents? What about them? No, because it's not a product. It's not a. I'm adding. You can't. If you have x squared plus y over x, you can't. That's a power 1. You can't do that because you don't have a product in the numerator. You have to have a product for it to be able to cancel, because multiplying and dividing is inverse operations. If you have this, then yeah, that will turn into xy. But if you have x squared plus y over x, that will not be xy, because you have a plus in the middle, so you can't factor out an x. Do you know what I mean? Only if it's multiplying and then you're dividing. Multiplying and dividing are inverse operations. Did I answer your question, Ethan? Kyle, did I answer your question? Okay. No, hit me, because I don't. Was that everything? Oh yeah. Okay, check it out, Houston. You're gonna love this. It's like McDonald's. I'm loving it.
What are you trying to say?
That I want McDonald's right now. I have this. How is this cosecant A secant A? Look, guys, you can just expand it. Yeah, they're reciprocals. You can do this. Look, 1 over sine A times 1 over cosine A. Isn't that the same as what I have on the left? And what's 1 over sine? Cosecant. Keep the argument. What's 1 over cosine? Oh, look, product. Cosecant A, secant A. Isn't that what they wanted? Yeah, that's exactly what they wanted. So you're going to put 3 little dots in a triangle, and you're going to say cotan A plus tan A equals cosecant A, secant A. What do you guys think? Yeah, please.
So then cosecant would come after we flip them?
No, cosecant comes right here. And there's my secant. Check out. Remember the first page of notes? Right here.
Oh, right.
It says, what does it say? 1 over cosine is secant. 1 over sine is cosecant. And you also know that those are reciprocals, right? All right, we're good, guys. We're doing pretty good. We got 2 left. 1 minus cosine B over sine B. We're trying to prove that this really is sine B over 1 plus cos B. So, yeah, I'd agree that these can be kind of difficult or kind of tough, maybe a little bit. What makes this tough? What's making it, what? So here's what you ask yourself. You look at it and you're like, can I do anything with that sine B? Like, no, that sine B is sine B. It stays like that. What about that 1 minus cosine B? Well, I mean, it's not a square, but this, we can do something about it. The 1 minus cosine B. That's what makes it, that's what making this hard. Does that make sense? So that's what I'm going to mess with. That's what I mess with that. Here we go. I'm going to write 1 minus cosine B over sine B. And remember, the numerator is what's making it tough. So the numerator is what I'm going to mess with. I'm going to multiply this by the conjugate of 1 minus cosine B. Yeah, okay. Let's rewind. Yeah, let's rewind. When you were with Ms. Gonzalez and you had 1 plus 3i, and Gonzalez told you, give me the conjugate of 1 plus 3i. What was the conjugate?
I don't remember.
You don't remember? Complex conjugates? Okay. Complex conjugates. If you have one that was 1 plus 3i, the conjugate of that is 1 minus 3i. So, yes. So the conjugate of 1 minus cosine B is going to be 1 plus cosine B. Now, this is magic unless you make it over 1 plus cosine B again. Let me explain. 1 plus cosine B over 1 plus cosine B is just 1. And anything times 1 is itself, so nothing has happened. Like, we have not changed the value of it. Now, if we just multiply by that, then that's magic. So for good notes, when you guys are doing this, make sure to put 1 plus cosine B over 1 plus cosine B. Cool or not cool? Okay. When you do that, here's what we get. Look what we get, guys. The top is like the difference of squares. So you're going to get 1 minus cosine squared B. And on the bottom, don't distribute. Sine B, parenthesis 1 plus cos B. Now, if you have a problem, I mean, I don't want no beef, but if you have a problem, you could just distribute them in case you're wondering, like, how did you get that so quick? 1 times 1 is 1. 1 times cosine B is plus cosine B. And then negative cosine B times 1 is minus cosine B. And then negative cosine B times positive cosine B is minus cosine squared B. Notice that the middle ones leave or delete. 1 minus cosine squared B is what I have in the numerator. Are we still okay? Okay. Now what, Chav? I have no idea. How am I going to get this answer here from this? All right. Focus. We're almost done. I'm going to go to cosine squared B plus sine squared B equals 1. Side note. My Valentine's formula. I'm going to move the cosine squared to the right and look at this. Sine squared B is equal to 1 minus cosine squared B. Do you guys see that? Okay, I'll wait for you guys to catch up. Are we all right? I have to entertain myself. 1 minus cosine squared B, isn't that just sine squared B? So that's what I'm going to substitute. I'm going to substitute that right here. So I'm going to circle this so you guys can see, and I'm going to put the word sub. So here's what I now have. 1 minus cosine squared B is the same thing as sine squared B over sine B, parenthesis 1 plus cosine B. Yes.
Can we factor out? No, right?
Well, now you can cancel. Why can I cancel now?
Because it's a square and it's just...
Yeah, in the bottom, it's being multiplied. Do you guys see that? So, and on the top. So now you can cancel. What can I cancel?
Sine.
1 sine. Yeah. Bam, out, and 1 of these. So now I just have sine B over 1 plus cosine B. Is that what they had on the right-hand side? There it is. Happy face. And we're going to put 3 little dots in a triangle. And we're going to say 1 minus cosine B over sine B does in fact equal Sine B over 1 plus cosine B. Yeah, you did it. 10 those deep. Big stepper. Yeah, I'll stop. Have you guys heard that jam? It goes pretty hard. It goes pretty hard. Oh, that the last one? Look at that. Go to your activity. We're going to do 1, maybe 2 together. I don't know. You guys ready? Don't worry. Look, that's what we're going to do. That's what we're going to do at least 1 together right now. All right. Here we go. You guys ready? I'm looking at it, and it says for the 8 questions below, show the steps in transforming the expression on the left into the one on the right. Okay. And I'm looking at this right here, and I'm like, man, where do I even get started, right? Look at the cosecant squared x minus 1. Go back to your identities and look for an identity that has cosecant squared x. And I see it. It is the third bullet. Do you guys see that? From this third bullet, so let's see, cotangent squared theta plus 1 equals cosecant squared theta. That's what I'm going to write. Side note, and I already forgot it. Yep, that's exactly what I'm going to do, Houston. Cotangent squared x plus 1 equals cosecant squared x. And exactly what Houston said is what I'm going to do. What am I going to do? Move over the 1. So if I move over the 1, I now have this statement. Cotangent squared x equals cosecant squared x minus 1. I'm going to replace the cosecant squared x minus 1 with what? Cotangent squared. So I'm going to go cotangent squared x over cosine x. Now what, Chav? I don't know what to do next. I'm going to expand it like this. You can say cotangent squared x over 1 times 1 over cosine x. To show that it's a fraction. Well, you can always put a 1 there, see? And then just break it up, right? Because if I multiply this on the right, will I get this on the left? Yeah. That's a hack. What is cotangent? What over what? Perfect. Because it's squared, you got to keep the squared. Cosine squared x over sine squared x. That's your cotangent times 1 over cosine x. And let me make sure to put this for good notes. This is still your cotangent squared right there. Don't worry, guys. I'm slowing down. What can I cancel out? One of them. Bam, bam. I should have used blue. Bam, bam. Okay. And now I have cosine x over sine squared. Chubb, I still don't have that answer. Cotangent, cosecant. Let me show you. Don't worry. We're almost there. Maybe Houston already had it. Were you saying already something, Houston, about that?
So wait, would it be sine x plus 1 is equal to cosine x?
Sine squared x is equal to 1 minus cosine squared x, but that's not going to help us here. Don't worry. We already got the answer. Check it out. I'm just going to expand this, guys. You guys already have the answer. You just got to expand it. You just got to open your eyes. So look, cosine x over 1 times, cosine x over sine x. Cosine x over sine x times 1 over sine x. Isn't that sine squared in the denominator? Yeah, if I multiply that, isn't sine x times sine x sine squared x? Yes.
Oh, we have to expand it more.
No, we're pretty much done. Look at this. Look at this. What is cosine over sine? That's cotangent. What is 1 over sine? Cosecant. We got it. Bless you. So cotangent x, cosecant x. 3 little dots in a triangle. Cosecant squared x minus 1 over cosine x does in fact equal cotangent x, cosecant x.
So those last two, right? The cosine x over sine x times times 1 over sine x.
Yeah.
You got that by expanding the cosine x over sine squared x, right?
I got yes.
Okay, that's where I was thinking. So I was like, where'd you get that? Okay,
All right, guys.
wait, don't move.
Okay, tell me, what do I do?
Okay, so first I use the first step formula.
Okay.
So then it's cosine squared theta plus sine theta equals 1. And then I move over the cosine.
Okay.
So sine squared theta equals 1 minus cosine squared theta.
Okay.
And then with that, I was able to get sine squared x over 10x equals sine squared x over 1, because we're expanding it, times 1 over 10x.
Okay, which is that this right here is cotangent, right?
Yeah, so then it's sine squared x over cotangent x squared x.
No, sine squared 1 times cotangent x. Yes.
Okay, so cotangent is also equal to cosine x over sine x.
Okay, so let me write that down. Cosine x over sine x, all right.
You can cancel out a sine x, so then that would just give you sine x times cosine x.
Perfect. Which is what you want. Good job, guys. Good job. Do the next one.
Wait, I have a question. So
Yeah.
why did you multiply cosine x in the numerator?
Well, you told me that 1 over 10 was cotangent x. And cotangent x is cosine over sine. Right? Because this is still cotangent x right here.
That makes sense. Oh, so that you can cancel.
All right, guys. Check. Do number 3. Okay, tell me, what do I do? One plus cotangent squared theta equals. Oh.
Wait, this is 3, sorry. We only opened 4, not 3.
Okay, no, that's fine. Let's do number 4.
Okay, so you write out 1 plus cotangent.
On the side? No? Okay. 1 plus cotangent squared theta over secant squared theta equals. Okay.
Wait, oh my gosh, I was looking at question 4, sorry. Okay, so you're gonna write cotangent squared theta.
Cotangent squared theta plus 1 equals. Okay. What do I do with that?
You're gonna plug that into your numerator, so it's gonna be plus secant squared theta over secant squared theta.
Okay.
And that's gonna equal cosecant squared theta over 1 times 1 over secant squared theta.
Okay.
And that's gonna equal 1 over sine squared theta.
Okay.
Times cosine squared theta over 1.
Perfect.
And then that's gonna equal cosine squared theta over sine squared theta times, and that's cotangent.
Yep. Cotangent what?
From here, squared.
Good job.
Do you want to break it down? I'll type it.
So number 5, I have this. I want to subtract them. You can't subtract until you find a common denominator. So I'm going to take the secant A over sine A. And I'll multiply this dude by cosine A over cosine A. And then minus the sine A over cosine A. And I'm going to multiply that dude by sine A over sine A. When you do that, you're going to get this. You're going to get cosine A, secant A. Those are reciprocals of each other. That's a 1, but I'm going to go ahead and leave it in there for now. Over cosine A sine A minus sine squared A over cosine A sine A. Since the denominators are both the same, I can rewrite this as cosine A secant A. You can always turn that into a 1 whenever you'd like. I just keep having it here. Cosine A sine A. What do y'all think? We're all right? 10 toes in. Okay. Big step up. Okay. All right. Cosine A secant A, that's just a 1. 1 minus sine squared A over cosine A sine A. Whoa, 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 whoa. Whoa, whoa, whoa.
Whoa. Where did you get that one from?
Oh, cosine and secant A cancel each other out. Cosine A and then secant is 1 over cosine A. So, true. It's just 1. They're reciprocals of each other. Almost. 1 minus sine squared is what? Cosine squared. And now, what can I cancel out? 1 of the cosine A's. What's cosine A over sine A? Cotangent of A. And there it is. Cool or not cool? Cool. All right. I think you guys can take it all the way now.